Okay, welcome. It's Wednesday, August 13th, and we're going to keep working on this idea of taking a number line and wrapping it around a circle, just like a string goes around a yo-yo. So as we wrap that string around the yo-yo, it's going to mark off an arc. And that arc is going to have a set of points that are related to whatever the angle is that is created by that arc. So you're attached to Google Classroom today. There's a simulation, and you're going to click on that, and you'll get a page over here that looks like this, where I've got a unit circle. Okay, the things that you're going to set up on here is you want to click radians. Over here, you can click cosine. This one really doesn't matter just yet. And then click special angles, labels, and grid. All right, now, what the special angles are, these are the angles in the common angles that we use in a unit circle. And they're marked over here. Okay, we've got pi over 2, which is a quarter of a circle. The top of the circle is 2 parts, the bottom's 2. Okay, the next is pi over 4. That's when we cut the top of the circle into 4 parts. So our circle would look like this. Pi over 3, we cut the top half of the circle into 3 parts. And the bottom into 3. And then this arc length right here is pi over 6. So the top half of the circle is pi over 6, there's 6 pieces, and the bottom of the circle is 6 pieces as well. Okay, now what we did yesterday was we had a number line and we wrapped it around the circle. And we had different points on here, and we just bent this around the circle. And where it ended, we found the coordinates for it. Well, that's exactly what you're doing today, except you're just using this animation instead. All right, so let's take a look at the first question over here. Okay, it's asking, okay, the point on the unit circle that corresponds to theta equals pi over 2 is P equals blank. So what it's asking for are the coordinates. All right, so pi over 2, that's positive, so I'm going to go counterclockwise. So I'm going to click on this red dot, and I'm just going to move it to pi over 2. Right over here are my coordinates. So the coordinates for pi over 2 are 0, 1. Okay, my next one is pi over 3. So take it back to 0. That's pi over 6. This dot is pi over 3. It shows it right here. Angle's pi over 3. And the coordinates of that endpoint would be 1/2 root 3 over 2. So if we wrapped a circle, if we took a line and we measured off pi over 3, okay, and that's just 3.14 divided by 3, guys. Okay, so pi divided by 3, okay, probably kind of hard to read on my calculator. Yeah, it is. Okay, well, that's 1.05. So if we measured off on that line here, 1.05, that vertical line that we're wrapping around our circle, if we measured off pi over 3, which is about a little bit more than 1, and wrapped it around, it would land right there. Okay, what if we wrapped pi over 4 around? Okay, so I'm going to go pi over 4 is that length right there. And its coordinates, the length of this blue arrow right here, is root 2 over 2. And the length, this height right here, is 2 over 2. So this has the coordinates root 2 over 2, comma, root 2 over 2. And then the last one is, if I move this length, if I wrapped pi over 6 around the circle, that would be the end point of this arc right here, pi over 6. And its coordinates are root 3 over 2, 1/2. All right, now the next 5 questions are just like these. It's saying if you took the number s at negative 9 pi, okay, negative 9 pi, guys, so if I went negative 9, let me do it on my calculator. All right, negative 9 pi is negative 28.2. So if I went over to this unit circle and I started right here at 0, 1 and I went down negative 28.2 units, could be centimeters, inches, doesn't matter, and then I wrap that around the circle, where would it end up? Okay, so that's 9 pi, negative. All right, so negative means I'm going to go clockwise. Okay, if you look over here, that is negative pi, so that's negative 1 pi, negative 2 pi, negative 3, negative 4, negative 5, negative 6, 7, 8, 9. Negative 9. Okay, now that would read right there. That should be negative 9. I think there's a little problem with the animation because we went around so many times. But that's negative 9 pi, and its coordinates there would be negative 1, 0. Okay, now if I undid that and I went around, click on my things again. If I went around 9 pi, I'm just going counterclockwise. 1, every time around is 2 pi, so that's 2 pi, and let me get on radians here, 2 pi. Okay, around again is 4, 6, 8, and now halfway around the circle, 9. And again, there's something weird happening with our program. That would be 9 pi. So our coordinates, again, are negative 1, 0. All right, negative 5 pi over 2. So 5 pi over 2, guys, let's reset this. Okay, pi over 2 is a quarter of the circle, and we're going negative. So when I count on this, go rads, this would be, let's see, I'm negative, so this is negative 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Okay, now you're like, well, wait a minute, Kroll, that doesn't look like negative 5 pi over 2. Okay, well, that is the same as 5 pi over 2. I'll show you right here. Okay, negative pi, 2 pi minus pi over 2. Okay, well, if I change that so I can have the same denominator, I'd multiply the top and the bottom by 2. And now the fractions have the same denominator, so I subtract the numerators, and that's negative 5 pi over 2. So the coordinates of that are 0, negative 1. Okay, let's reset. All right, our next one is negative 7 pi over 6. So pi over 6 is the skinniest slice here. So I'm going to count negative 1, 2, 3, 4, 5, 6. Okay, so I'm counting, let's see, right over here, guys, I counted this way. 1, 2, 3, 4, 5, 6. Okay, let's switch this over to degrees. Okay, 7. So there's negative 7 pi over 6. And my coordinates would be negative root 3 over 2 and 1/2. All right, positive 2 pi over 3. So 2 pi over 3 is these slices right here. That's 60 degrees. And there's 3 of them on the top and 3 on the bottom. I want to count 2 of them. So there's 1 pi over 3, 2 pi over 3. And my coordinates would be negative 1/2 root 3 over 2. All right, and our last one. If the length of the arc was 5 pi over 4, what would the endpoint be on the edge of the circle? So we go rads. Okay, pi over 4. That's dividing the top of the circle into 4 parts and the bottom into 4 parts. So that's these middle dots. So I go, there's 1, 2, 3, 4, 5. And that endpoint would be negative root 2 over 2, negative root 2 over 2. So by moving this around, that's the same as wrapping that circle, wrapping this line, I mean, around the circle, and this red dot represents where the endpoint of that string would be after you're done wrapping the angle. So you're going to use this simulation to complete Math Excel, I believe it's number 6. And I'll see you next time. Bye-bye.